Okay, so we're gonna do 5.6 today, ratio and root test. So this is really easy, but we have to know the factorial first. So we never seen this one before, factorial, right? So the symbol is like this, okay? Look, we called this one, we read this one n factorial. Not the head. Did I scare you? So sorry. M factorial, we read like that. Okay, then we start the number and then reduce by 1. Each number we multiply with, all right? So look, for example, we have 2 factorial, 2 times 1, which is 2. 3 factorial, which is 3 times 2 times 1, which is 6. 4 factorial, which is 4 times 3 times 2 times 1, which is 12, 24, okay? 5 factorial, we know that, right? So 5 times 4 times 3 times 2 times 1, which is 24 times 5, 120, okay? So now you guys notice that, right? Let's go back. How about 1 factorial? It's 1, okay? And 0 factorial, weird, it's 1 as well. Okay, this one only I can explain to you this way, all right? So I'm teaching statistics, I explain to my students this way. So look, for 5 factorial, we can say that 5 times 4 factorial. Do you agree?
Yes.
Okay. Now, 4 factorial, we can express 4 times 3 factorial, right? Correct? Now, 3 factorial, we can express 3 times 2 factorial, right? Now, 2 factorial, we can express, this is 2 times 1 factorial, right? 1 factorial, we can express 1 times 0 factorial. By the pattern, can you see that? Now, but we know that 1 factorial is to 1, then 0 factorial must be equal to 1. Make sense? So 0 factorial, we said 1. 1 factorial is the 1, okay? All right, so this one we are using for statistic and combinatory subject. So we have how many times we can arrange the stuff or combination or permutation, we are using factorial, okay? All right, now.
Ms. Lee, can you scroll all the way up?
Okay.
I just wanted
this
to
is
see
the first one.
This is the 5.6, okay. Thank you.
All right, then we're gonna do ratio test today. So we're gonna use a factorial a lot, okay? Now, in the book, they mentioned that we know the series 1 over n squared is approach to 0 when the n approach to positive infinity, right? So let me write down. So series. On previous. So we have we know this is what? Converges or diverges?
Diverges.
Hmm?
Oh, converges. Sorry. Yeah, it's 1.
Why? Why converges?
It was less than 1.
Ah, we're gonna say that by the sum of test. I know the one person really good in this. Ah. So converges by geometry, I'm sorry, geometry, P series. Yes. Now, okay. P equal to 2, which is greater than 1, right? But then, look, if we take the limit, 1 over n squared, approach to what? It's
0.
0. Yes, thank you, it's 0, right? But we know that series 1 over n is diverges. Why? Does anyone remember why this is diverges?
Is that the harmonic?
Harmonic series, right? So this is a harmonic series. Or P series, the same thing, right?
Oh yeah, I always
Mhm.
forget that.
Because P equal to 1, right? So harmonic series. Or P series. Okay, and in this section they talk. Also, if we take the limit of this one over n, also approach to 0, right? We know that, okay? This means why this one is same, we take the limit, is approach to 0, and this one approach to 0. Why this is converge, why this is diverge, right? Because this one approach to 0 more quickly than this one. Okay, so in the ratio test, we're gonna provide, the ratio test provides that, I'm gonna read the textbook, which provides a way of measuring how fast the terms of a series approach to 0. Okay, so let me write down. Provides a way of measuring how fast the terms of the series approaching 0. Okay. So let me bring the screenshot here. Wait, I'll be back. Don't worry. So there's a ratio test. Oops. Oh, no. This one. Good. 5.6. Okay, so you can write down, right? Oh, no. Paste. Okay, so this is the one. Okay, so theorem 5.16 ratio test. So ratio test, look. We're gonna make this form with the absolute value. So we had the experience about this, right? So we had a to the n over b to the n. We take the limit, okay, from the limit comparison test, okay? But in this case, we have a sub n plus 1. We're gonna make that on the numerator. So this one is not hard. We just substitute n plus 1 into the n, okay? Now, if, okay, we called this is a rho in Greek. Rho. Okay, we read rho. Then this rho is between 0 and 1, includes 0. Then the whole series converges absolutely, because we take the absolute value, okay? If the rho, not the p, rho is greater than 1 or equal to positive infinity, then we say that the whole series is diverges, okay? And rho equal to 1, the test inconclusive. Okay, we cannot tell anything about that. Okay. All right, so let us do this. Look. Determine. Whether the series converges or diverges. So determined by that, by rule. Okay. All right. So we have series n equal to 1 to positive infinity. We have 2 to the n power over n factorial. Okay. So we're gonna make this a form, all right? So look, rho, limit, and approach to positive infinity. We say that 2 to the n plus 1 over n plus 1 factorial all over should be middle. 2 to the n, just rewriting this one. That's the a sub n, right? So we create a sub n plus 1 there. So 2 to the n over n factorial. Okay. Now, this means we have a limit when n approaches to positive infinity. 2 to the n power. We have the same base. We add their power. So that's the 2. Okay. Over n plus 1 to the factorial, right? And times with the reciprocal of a second fraction all over 2 to the n, right? Okay, I am split 2 to the n plus 1 power to the like that, right? Because I want to simplify this one, all right? So look. And then look, n plus 1 factorial before that, we have n, isn't it? Yes. So we can simplify n factorial with n factorial. Can you see that?
Yes.
Yes, very good. Then we will have limit when n approach to positive infinity. And we have 2 over n plus 1 remain there, right? Now, how do we determine the limit? If you cannot say, you can write down this way, much better to look.
Oh, is it just 0?
Hello.
It's 0 again. Okay, so constant divided by huge number is 0. Okay, no, it's 0. That means less than 1, right? So then look, how do we determine 0 is included there? So we said the converge absolutely, right? So first of all, I have to make absolute value. But in this case, it's okay because we don't have a negative sign, okay? All right, so we can say that converges absolutely. Absolutely by ratio test. Why? The rho is equal to 0 is less than 1, okay? All right, second one, we have the summation from 1 to the infinity. And then we have n to the n power over n factorial. So we will write down, this is a rule, equal to, we take the limit, n approach to positive infinity. We don't need the actually absolute value because looks like everything the positive. So we plug in n plus 1 there. So use limit n approach to positive infinity. Okay. Use limit n approach to positive infinity. Okay. So it's a n plus 1 over n plus 1 factorial or over, we're gonna rewrite the a sub n. Okay, then this will be a sub n over n plus 1 to the n. And then I want to make, is it, we can not do anything? Okay, so we cannot do anything. Or over n plus 1 factorial. Then let's say times reciprocal of that, so n factorial over n to the n, right? We have that. If you want, you can take the absolute value, but it's not really matter. All right, look. When n approach to positive infinity, once again, we have n before that, before n plus 1. So we can simplify. Oops, almost did that. All right. Then, oh, we can simplify, right? So I'll show you one more steps. So we have n plus 1 to the n power and n plus 1 to the first power, right? Or over n plus 1, then times n to the n power. Yeah. Okay, then we can simplify.
Mrs.
We
Lee,
have-
one question.
Uh-huh.
I still don't get it why you added n, the purple n.
Okay, so the factorial, we have to understand the factorial. So factorial, look, we have a factorial using this symbol, the exclamation, right? Exclamation, this symbol, and n factorial. Then we start with this number, n start, and then reduce by 1 everything until 1 with the multiplication. Make sense? Okay, then
Yes.
2 factorial, we start to 2 times 1 until 1, right? 3 factorial, start to 3 until 1. Okay, so we have n plus 1 factorial. We have to have a n plus 1. Then we have n factorial. Can you understand this one? Okay. In other words, look, we have 5 factorial, right? We start at 5. Then next one we can make just a 4 factorial.
Yes.
Make sense? So every time we start with the factorial, just before that, we have n factorial as well. Do you agree?
Okay.
Yeah.
Okay.
Yes. Okay. That's why we simplify. So factorial simplify, factorial simplify. Okay. All right. Oh, here. Then we get Look, we have n power. So we're gonna write down this one, n plus 1 over n to the n power. Then, this one looks like this. We simplify, right? So it's 1 plus 1 over n to the n. It's okay? So n over n, which is the 1 over n is there, right? Does anyone recognize this one? From previous? How about this? You might recognize this one then? Do you recognize this? No one recognize? Okay, this is E. So do you remember I said, looking at using this
that one.
one? Yeah?
Yes. E to the 1.
E to the 1, yes. I said that. Looking at the e to the 1, right? Okay, so that is the 1, okay? All right, then e to the 1. E is the real number, which is 2.718186, right? So this is greater than 1. Okay, so then if the row is greater than 1, how can we determine its diverges? Okay. Diverges by ratio test. Since the row is equal to E greater than 1. Okay. All right. That's the third one. What do you mean one? You mean this one or this one? This one? Yeah, so E means just E. Yeah. Okay. All right. Okay, your classmate explain in the chat. Good. Okay, let's see. Third one. And to the positive infinity, we have -1 to the n. In this case, we need the absolute value because we have alternating series there, right? So we have n factorial squared over 2 to the n factorial, okay? All right, so we need the absolute value because we don't want the negative alternating sign, okay? So in this case, rho equal to, take a limit. We're going to take the limit and approach to positive infinity. So we have a -1 to the n plus 1, right? So use limit a sub n plus 1 over a sub n, right? All right, so look, we have n plus 1. We have to be careful. N plus 1, we plug it into the n, then factorial there, isn't it? Then doesn't look good. So let's say that n plus 1 parentheses factorial and then squared all over and 2 n plus 1 then factorial, right? Okay, now let us just rewrite with a reciprocal. So we have a 2n factorial there over -1 And then I want to change it to n, then -1 to the 1. Right? Okay, hold on 1 second. Let me just write down. Anyway, we need to do one more step. Okay, so n and the n factorial squared, right? Okay, I did not make a mistake, so you can check that too. All right. So there's this. Can you see that this one, we're gonna split -1 to the n power, then -1 to the first power. Let's just leave it like that, and then we do distribute to this one. N plus 1 factorial squared, right? And we have a 2n factorial, okay? Over, we have 2n plus 2 factorial, right? All right, then there will be -1 to the n power, and then we have an n factorial squared. Okay, let's think how much we can simplify that, right? Look, what can we? So 2n plus 1, so we have a 2n plus 1 and 2n plus 1, right? Before that. And then before that, because we want to simplify this one, 2n factorial. So we can say that before the 2n factorial there. Make sense? Let me write down for you. We can express 2n plus 2 and 2, what's wrong? 2n plus 1, 2n factorial. Yeah, okay. So we can simplify 2n factorial with a 2n factorial there. That's it. How about others? 2n plus 1, 2n plus 2, 2n plus 1, then n plus. Okay, so this means, look, n plus 1 factorial square means, okay, this means n plus 1 factorial, n plus 1 factorial. Yeah. And then we have n factorial squared means we have n factorial times n factorial, right? Okay. Then, no, sorry, this is a little bit complicated. So before n plus 1, we're gonna have n, right? So basically n plus 1 times n factorial, right? And n plus 1 factorial again, and we have n again. Make sense?
Yes.
Okay, good. Let me explain one more time. So n plus 1 factorial means we have n plus 1 start and then reduce 1 there. We can express this way. And we have n factorial means we can start n, then n minus 1 factorial, right? Because for your reference, for your information, because we have a 5 factorial, which is we start at 5 times reduced by 1, which is a 4 factorial. It's the same as, okay? All right, then. Ooh. Let's do a little bit smaller so that I can see that. So we have limit when n approaches to positive infinity, we have -1, and then n plus 1 factorial squared, we say that right, so n times n plus 1 factorial, then n times n plus 1 factorial, right? Then over, we have 2n plus 2 and 2n plus 1 and n factorial. Yes, we can do that. So, oh, we don't need that one, right? Yeah. So this is not necessary. Yeah, because just your reference for your information, for your information. Okay. Okay. So everything okay? All right, then let's do simplify. So n factorial. Then let's take out the absolute value. Then this is +1 without absolute value. This is what we wanted to take the absolute value there. n plus 1 all over. We have 2n plus 2, 2n plus 1. Okay.
n plus 1 and the 2n plus 2 can simplify.
How? All factorial with 2?
Yeah.
Okay. Good idea. So with that, okay, then you might a little bit confused. So we take the limit, right? I think it's better we keep this one, right? Because the limit. Then where is n? So we keep the n. Okay, if you don't get it, then how about this? So sorry, maybe we do 4n plus 4. Okay. Okay. So now you can get it. This is better. Yes.
Oh, why we have 4 plus 4?
I'm sorry. So sorry. 2. Yeah. Thank you. All right. This is better. Yes. Because anyway, we have to multiply out. If you cannot see it right away. All right. So if you cannot see, how about this? 104. Now you can see. Okay. So how do we determine that? Is it converges or diverges?
Diverges.
Diverges.
Converges. It's converges.
Converges.
Converges?
It's less than 1.
Less than 1. Okay, so it's converges. Okay, by ratio test. Since the rho equal to 104 less than 1. Okay, good job. So it's not that hard compared with limit comparison test, alternating series test, and absolute convergence, right? Just algebraically more work. That's it. Okay. Okay. Now we're gonna do root test. So root test is very similar to the ratio test, but then I said that number one easiest one is the P series. Number two is the root test. Number three, ratio test. Number four is geometry series. Okay. Okay, so relax, root test, second easiest one. So easily to recognize root test. Ratio test, if we have a factorial, right? That is 100% sure, 100%, okay. Probably maybe a little bit different, but yeah, 99% sure you're using ratio test, okay? If there is a factorial. And, why this one? I don't have one? Oh, root test here. Okay, root test is the same, so very similar with the ratio test. Okay, so we have series. We take the absolute value inside, right? Okay, then we take the limit. We say that this is rule. Then the same converges absolutely. That rule is between 0 and 1, inclusive the 0. Okay. Then greater than 1 or goes to positive infinity, then diverges. All right. Okay, let us do this one. So the root test, when do we use? Looks like here. So every time there is n power, we have two questions there. Divergence. Is second to the n power over 4n to the second power 5 to the second. I'm the second, not second, 1 second. N power. Okay, can you see that? Okay. Well, every time we see the whole thing, whole fraction is we can express this as a whole thing and power, right? Okay. And we can use a root test. Because root test, we can have it like that, and then we can simplify, all right? Okay, so let us do that. Let us say that this is a rule. Limit to 7. Okay, so you can use like that, or you can use 1 over n power, that's fine. So let me show you. Absolute value, n to the that, or n squared plus 5, okay, to the n, then 1 over n. Yeah, we can simplify, right? So n gone, right, to power. So we have This one, we don't need the absolute value because there is no negative. All right, so then we have n squared plus 3n over 4n to the second power plus 5, okay? So we take the dominant term, so we have n approach to positive infinity. Now n squared over 4n to the square, that is 104, right? Okay. So how can you determine this one? Converging or diverging?
Converges because it's less than 1.
Okay, so it's converges by you test. Since O equal to 1/4 is less than. Okay, so one last one, second one. We have a series n to the n power over ln n to the n. Okay, use the limit n approach to positive infinity and a7.
Miss Lee, I have a question of the previous one. So what happened with the 3n and 5?
Okay, so when n approaches to positive infinity, I gave you a tip previously, right? We take the dominant term, okay? Otherwise, you have to do work. So what you do, work
I see.
like that, right? But I gave you a tip earlier, right?
Yes.
Okay, so when I approach it to positive infinity, that's 0, that's 1 and 1. So this will be 3 to the n, right? So this will be 0, right? And this is 1, and this is 4, right?
Yes,
So
thank
which
you.
is 104. But I gave you a tip, just take the dominant term, right?
Yeah, that's
The dominant term.
easy. Yes, I think so.
Because it works only the n approach to positive infinity. So we had a calculus 1, x approach to positive infinity or negative infinity, right? So compare with the other term, it's the highest power is the huge, right? Yeah. Okay. This one, rho, which is the, we can say that limit n approach to positive infinity. We have n over ln n to the n power n 1 over n, right? Oops, absolute value. Okay, then we know that n simplifies, so we have a limit n approach to positive infinity. Okay, then we get n over ln n. Okay, so when n approach to positive infinity, what do you get this one?
Infinity.
Okay, so this is infinity and ln n. So think about the ln x. When x approaches to positive infinity, what's the graph behavior?
Infinity.
Infinity, right? We've seen this one before. Where? Indeterminate form, isn't it?
So how to use L'Hopital's?
Excellent. So we're gonna use a L'Hopital rule. So then we're gonna change that. F of x equal to limit x approach to positive infinity, x over ln x. Okay. So infinity over infinity. So L'Hopital rule So we do derivative. Okay, so what do you get? Numerator,
It
Just
will be 1
One-
over
1 over x, excellent. You are the expert of ln(x). So we get limit, when x approaches to positive infinity, we have x. What do you get this one then?
Infinity.
Infinity, so it's diverges, right? So diverges. All right, good test. Since equal to infinity. Okay. All right. So that's it about the today's lecture. Thank you for coming.